Welcome, everyone. Thanks for joining today. I'm Abby Lindberg, Director of Applications Engineering here at GelSight. Today, we're going to be talking about some little-known features in the GelSight software, really focusing on our AI design module, and we'll also talk about our capture with reference functionality as well. A couple items before we get started. We'll have Frank Chang from the applications team answering questions live using the chat throughout. I'm not sure if the Q&A is working, so go ahead and check out the chat functionality. He'll be answering questions there. And then with us today, we have Thierry Mantel. So I will pass it over to him to introduce himself and kick off the webinar.
Yeah, thank you, Abby. Hello, everyone. I'm Thierry Mantel, so I'm the Vice President in charge of the GelSight distribution network and some key accounts. The introduction of AI tools at GelSight is interesting since it has been oriented to solve customer problems since day one. A few years ago, a customer came with metallic roads having defects at the surface of these roads, and he wanted to find a way to discriminate the good parts from the parts which needed to be rejected. So we started with a very classical approach, trying to measure, the length, the depth, the surface of the defect. But this was taking too much time, to be implemented in their industrial process, and they wanted to have, pass-fail criteria, being able to once again select the right part from the bad parts. And so we proposed an alternative approach based on machine learning. So we basically taught a model to discriminate the good parts from the bad parts, and this was really our very first application using a machine learning approach. The second customer had some challenges with the surface finish of aluminum casings. Depending on the parameters of some surface treatment, their parts were presenting a different tactile experience for the end user. And same thing, we started with a classical approach, trying to measure rough test parameters, and they did it also on their own side using their confocal microscope. And same conclusion, we were not able to identify parameters which were able to discriminate the surfaces of their aluminum casings. And we decided to use this AI tool based on the same thing, the machine learning approach. And we taught the system with some samples to be able to discriminate those surfaces. And we had a very good surprise that the model was able to select and classify the different families of surfaces. And this is something which convinced us to implement GelSight AI design in our GS Mobile software. These two examples are just using basic approach of machine learning, but it opens really a huge field of application. And I just talked about the classification of surfaces or parts, but Abby will enter into more detail about the segmentation and detection, which open doors really to a huge field of applications. In the domain of manufacturing, aerospace maintenance, manufacturing of parts are really, the targets. But we also have, people in the field of archaeology very interested by using a GelSight tool to better understand how, ancient parts have been manufactured and which kind of tools they used. Another, tool which will be demonstrated by Abby is the possibility to take a scan having an existing reference. And it's very interesting, when you have an existing part and you want to see, the evolution of these parts. But I will let Abby presenting these two models available in GelSight. Abby.
Thanks, Thierry. So I think before I jump over to walking through configuring these and going through the applications, we'll just do a quick overview of how GelSight works, and then we'll talk a little bit more about the algorithms that we have available in the software. So today I have our Series 2 system with us, and I also have our Modulus with the 16mm lens. So we'll go through both of those, but fundamentally they're working in the same way. So we have a camera, a lens, and an illumination system in here. And when I click the button, I'm taking a series of images, 6 images, one with each one of these illumination channels active. And we take those 6 images with the 6 different lighting orientations and use a process called photometric stereo to turn that into 3D data. And then all of that works in conjunction with our gel sensor, which for a lot of these applications is going to, for a lot of these AI applications is going to be one of the most interesting parts of it. You know, we're really looking at the way maybe something subjective about the way something feels or the way something looks that might not be quantitative, but you know, we're really responsive to your human senses there. So this can be a good fit for all of those. And this pigment layer on here is what lets us look at those surfaces regardless of their optical properties. So really just getting the way that something feels. So I'll pull up one slide before I share my screen here, opening the GelSight software. And these are the available AI algorithms that we have. So we have classification, detection, and segmentation. And we wanted to pull up this slide because I think it helps you visualize this. And it's kind of a classic example for this type of application. But the classification algorithm, which is the one that kind of applies to the examples that Thierry gave in the introduction here, this would be classifying your surface, in this case, into a category. So in this image, this is a cat. It would be this is a cat or this is a dog. But on a surface, this might be this is a 1, 2, or 3, or this is a good or a bad. And then detection will help you locate what's in that image. So it's kind of it's similar to classification in that you're saying what the image is, but it's saying what is in the image. So you might say there might be 2 cats. It might say cat, or it might be cat and dog in that image as well. And then segmentation is going to break it down into where that is located on like the pixel level. So it's kind of labeling the pixels to find that item that you've trained on. So with that, I'll stop sharing here. I'll stop sharing the slides, and we'll switch over to the video display where we'll look at the desktop here, and then we'll also share my software. And as I share my screen there, if you want the video to be larger, you can click on that. If you want the GelSight mobile software to be larger, you can click on that to kind of toggle between the two. So let me share the desktop here. We'll take a look at that. And then I'll share the GelSight mobile software as well. All right, great. So the first example that we'll go over is going to be that classification algorithm. And for that example today, I'll talk about different texture samples. In this case, I've got a hardwood sample here. So on the left-hand side of our software, we have an AI design module here. And this is where we can create and build our analysis function that uses one of those types. So to configure this, I would come in here and I select new, and I can select my model type, classification, detection, and segmentation. I'll actually just open up the existing one that I have here. We'll open up the hardwood classification example. And what I have here is I've added 3 different classes. So I have 3 different samples of 3 different types of hardwood. So we have one that was labeled flint oak scrape, one natural hickory, and one strand woven Tacoma. And what I've done is selected this button here, this plus sign, and loaded my scans into that. And what's nice about this too is, if you're collecting GelSight data and you're also performing quantitative analysis on it, and you've built up this library of scans that you've been working on for some time, you can just take that existing data and load it into here when you have a sufficient data set. So the recommended number of scans of each example, or what each class, is 100. The minimum's 20. I got away with 25 on this one here, but the recommended value is going to be 100. And obviously bigger would be better. So the more data you have, the more confidence in your results and your data set here. So basically we came in here, uploaded these scans. And I'll also point out we do have a couple customizable properties for the model training as well. So on the right-hand side here, a couple related to how the training actually is performed. And then we also have the ones that I use probably most commonly is this crop functionality here. So if your surface takes up the whole field of view of your scans, you can actually enable this cropping functionality, and it takes your scan and breaks it up into smaller squares, basically, so that you can have a larger data set out of smaller number of scans. So for now, I'll minimize that. And once you have all of that uploaded, you can train the model. And I'm not going to do that as part of I'm not going to do it live as part of this webinar. It takes, anywhere from, depending on how much data it is, it could be 15 minutes, it could be, an hour or two. So I've already trained this one. And I'll show you guys, I'll show everybody how that looks in our software. So I'll just come over to the capture page and we'll take a scan of the surface here. Something like that, this area here. And I'll just click the button to take the scan. And we'll open this scan up and we can run our hardwood classification algorithm. It just shows up on our list like any of the other ones. And this one has shown up with a classification here of strand woven Tacoma and a confidence score associated with that. Now, what I'll do, I'll go ahead and I'll go back to the capture page, because I'll also just show we can run this as a routine and select it from here, as opposed to having to go to the scan and click analyze. And we can also add pass-fail criteria to that too. Like maybe one of those types of classifications is considered passing. This could be your good and your bad categories. You can add pass-fail criteria to that as well, so that you don't have to make that decision later too. Now for the next example, actually we'll jump over to, we'll look at segmentation. Head back to our AI design model here, and I'll pull open one that we have here, Scratch Detect 2. And another sample that I have here is basically, it's just a piece of transparent material with some defects on it. And what we looked at for this algorithm was basically taking scans of different types of defects. And then what we'll look for in the result is those defects being highlighted. So we loaded all of these scans. I just did 20 here. Obviously, you'd have improved accuracy if you went through and did even more scans. But in each one of my training set, I defined where my defect is and labeled it as a scratch. So I'll exit that for now. And we'll head back over to capture and we'll take a look at what the result looks like from there. So with this, I'll find it's kind of hard to find the defects on the transparent material here. So we'll come in like that, something like there. And I'll just click the button to take the scan. So we'll open this one up here and we'll go to our Scratch Detect function here. And the output for that is going to include, that highlighted area of where that defect is. So we can see this function looked in my field of view here and found a defect and highlighted that, basically the pixel outline of that defect itself. And for the last example, that I have here, we're going to go through with the modulus system. And we'll find my sample. This one's a small one. We're going to go through and we're going to look at some OCR, some optical character recognition. We trained on some characters on this coin, on this penny. So we'll take a look at that one. Let me just switch out from our series 2 to our modulus system here. All right, we're just getting connected now. And let's go look at how this model is built. Slightly different than the other two that we've talked about so far. I'll come over here and we'll look at this one. And for this application, I took a bunch of scans of the text that I'm going to be interested in a couple different orientations. And for each scan that I uploaded into my data set, I drew a box around the characters, basically telling it, what character is this? Which one is this one? And which one is this one? And I'll go ahead and close that out. And we can see I've got the 20 scans in here, and it was trained and then deployed so I can run it from our capture page. So let's go to capture, and we'll take a look at the text on this coin here. So something like that. And I just click the button to take the scan. And we'll open this one up and we'll run our deployed model here. And we can see I've got O, N, and E to spell out 1 for the 1 cent here, and the confidence score associated with each one of those characters being detected here. Now, I think that we talked about at the beginning our capture with reference functionality. I think this one is a pretty good candidate to show that for, because if I go to Explore here, and we'll go into this folder. Maybe I have one kind of orientation that's the golden orientation, or I want my operators to have a reference for what the scan should look like when they take a new scan. And what I can do is click on one of these, we'll right click on it, and we'll select Capture with Reference. It'll bring me back to my capture page, and now I can look at this scan while I take my next scan. So now I might know, okay, this is what this scan is supposed to look like. I'll go ahead and take this one here. And I do know that this one actually works with the configuration with the text upside down as well. So we could even go ahead and clear this and take a look at the text in another configuration too, is I included both orientations in our training data set here. So we can take a look at that one as well. Got the same thing. We've got the O, the N, and the E, but upside down in this orientation. So I think with that, I'll pass it back to Thierry, and he can kind of summarize the value of GelSight for these types of applications, and maybe elaborate a little more on the use of capture with reference outside of this specific example. But I think we have just a lot of applications for it, and for predictive maintenance as well. So I'll pass it back to Thierry so he can discuss that a little bit.
Yeah, thank you, Abby. Thank you very much for this compelling demonstration. It was short but very, very efficient to demonstrate, the potential of these tools. And Abby, I've seen during the demonstration, these tools have been developed with, always the same GelSight spirit, the ease of use, a friendly user interface, fast and clear answers, and a tool which can evolve in time. And this AI design tool will continue to be improved and optimized, from the feedback we will receive from our customers. It's just a first step in a long-term approach. The machine learning approach brings numerous opportunities, to replace fastidious and subjective inspection. The first we have in mind, we talk about that with Abby many times, is to apply this type of model for the inspection of shot pin surfaces. Today, when you want to control, shot pinning on surfaces, you need to have an experimented inspector which examines visually the surface under a binocular, evaluates, the coverage of the shot pinning. This is fastidious. This is subjective. It's human dependent. You don't have a choice, and it's also tiring for the person who is doing that, the entire day. So we can really easily imagine, to train a model based on different sampling of samples of shot pinning, having different values of coverage, and develop a model to predict, the coverage of shot pinning with a pretty high degree of confidence. This is really, we have it in mind, and this is something we want to dig in. And of course, as soon as you will be able to do that, you will bring a very significant gain in terms of, productivity in your process and also reliability in the inspection. And in plus of that, which is independent on the AI aspects, but the portability of the GelSight system will also allow you to do direct measurement on the parts, especially if the part is large. Another example of these techniques is, the automatic detection of defect during maintenance operation in the aerospace industry. The segmentation of the defects on parts coming from a large fleet, like engines, landing gears, aerostructure, would really help in the understanding of these occurrences. It will bring really very detailed information to allow to determine, the root cause of these defects and to propose, corrective actions. It also, can play a crucial role in predictive maintenance because, you can anticipate, the need of long-term, long cycle parts, and also to minimize, your turnaround time when you have, engine to repair, which is those days the case. And you can check on by yourself on internet, but AI tools, can bring up to 15 to 45% in terms of productivity gain. There is independent studies demonstrating that, and we really strongly believe that this is just the beginning of the deployment of these techniques, in industries like the aerospace and also many other industries. And the modular architecture of GelSight technology, has been thought in the very beginning for an easy integration in an industrial environment. That the probes have mounting holes. They can be easily integrated at the end of a robotic arm. The API module is very well documented and allows a perfect integration and communication with the environment of the customer. And the AI design tool, you have seen today, open doors to new ways of analytics, and now it's your imagination. It's the way you will want to use it, which will make the difference. And now for the second part of the demonstration, the fact that Abby had the possibility to use a reference, when taking a scan, it's extremely useful to see the evolution of a crack at the surface of a part, to see the evolution of corrosion on some parts, which needs to be stored and during months and years. There is some products that they have to stay there, and of course our customers need to understand the way these parts evolve in time. And you can even use this type of tool, the reference, to understand the evolution of features on biological materials, such as the evolution of spots on fruits or specific features on the skin of some animals. And we have customers doing this kind of thing. So you see the spectrum of utilization of our tool is really large. And it's, once again, just a question of imagination to stop that. Yeah, I really hope you have enjoyed this session. We thank you very much for your attention, and the team will be more than happy to answer to your questions. I see there is still a couple of minutes for us to be able to answer to your questions, so don't hesitate to ask them.
Thanks, Thierry. While we wait for a couple of questions to come in, I'll just add a couple of things that I was thinking about as we were going through this. Another one being, some of the feedback that we've gotten about these applications that might be this visual inspection is that the operator variability, whether that's just specific to the operators or even the time of day on some of these inspections, is pretty significant. So having the digital version of that to reference and having GelSight making that decision, we've definitely seen, heard the feedback that we've decreased some of that variability compared to what they've seen just from their typical process there. And then how that can be tied back to these applications like shop peening, which is a traditional visual inspection for coverage as well, we think is very interesting. And I think one other thing that I didn't point out as we were going through this, I usually show the 3D reconstruction as part of the demonstration, but I didn't show any of that today. And our AI design functionality and algorithms actually aren't running on the 3D, they're running on the images that are taken when we click the button. Not a single image, but the image set that is collected. So really it enables pretty high speed classification. We don't need to reconstruct the 3D. We can just go right from the image collection, which is pretty quick on the system.
Yeah, just to give some quantities about the timing to build a model. A few days ago, I built a model based on different grades of sandpaper, and I took 100 scans for each grade. I had four different grades, and it took around 1 hour, 1 hour and a half to build the model, the classification model. So it's not too demanding, even when you have a large number of samples.
All right, I haven't seen any other questions come in yet. We'll hang out for another minute here. Other than maybe I'll figure out the hardware so I can show multiple videos. It's a work in progress over here. All right, well, thank you all for joining today. We'll end it here, and feel free to reach out with any questions. We'll be posting this recording to YouTube and sending it out once everything's uploaded. So thank you all.
Thank you, Abby.